Okay. A warm welcome to one and all. This is Atharva Bilash Patil, and today I am sharing my Nidhi Prayas screening presentation for my prototype development proposal to PDPU IIC. So, without further ado, let's skip forward to the main content. So, construction industry is a $200 billion industry in India. Yet, 13.5 million people in this country are homeless. A major chunk of this population comes from our urban cities, and a major chunk of that population are just small children. Can you imagine the plight of a small child who doesn't have a roof to sleep under? Yes, affordable housing is a crisis, big crisis in India. So is slum rehabilitation. So we as a company are working to address and solve these very problems in our country. So throughout this presentation, this is the content that we'll be going through. First, we'll see about us and what we are doing. Then we'll address our problems. Then we'll go for what solutions we are bringing to the table. Then we have our value proposition. What novelty and moats do we have? We'll analyze the market. Then we'll go for the ask and the action plan for this project. And finally, we'll introduce you to our superb team and mentors. So, telling you something about us, we are working on reduction in cost, time, and transportation problems in the precast industry. Also, how to improve structural performance of these projects under Pradhan Mantri Awas Yojana. So, basically, we are trying to make affordable housing at the cost of not compromising the structural integrity of the structures. Also, we are bringing new doors, opening new doors to the construction industry by introducing IoT and Industry 4.0 in a so-called non-conventional industry. Also, this IoT and this smart construction management will open doors to advanced supply chain management solutions and make the whole construction process very easy, efficient, and very time friendly. So, the pictures that you are seeing here are of lighthouse projects made under Pradhan Mantri Awas Yojana. These are made using precast technology, but the existing problem people, the inhabitants of these schemes are facing right now are the compromise on the structural integrity and compromise on the structural elements of these structures. What happens? Very low quality, very poor quality elements are being used to give them these houses at very affordable rates. Now, this is one solution which is existing in the market. It is called as precast blocks. So precast means the blocks are casted in a factory, then they are transported to the site and they are assembled in a lock and load structure. This makes construction very efficient as well as a very pocket friendly. But here each and every panel weighs almost 2 to 3 tons, and in one single truck only 3 to 4 panels can be transported. So this is the current problem we are facing in the precast technology, which is already there in the market. Okay, but due to the high dead weight of these panels, there are also many damages and breakages while transportation. Even if the truck goes on a speed breaker, the panels develop internal hairline cracks, and this is very devastating to the entire structure. So we are working on a solution which is very modular, easy to transport, and easy to erect. Let's move forward to our solution. So this panel we have constructed, it is called as a prefabricated panel. It consists of two parts. The first is the steel reinforcement that you are seeing in colored. It is color coded with different types of steel reinforcement, which is compression steel, shear steel, blue for tension steel, etc. Now the sheet that you are seeing at the bottom is an intelligent sheet. It has been induced with an RFID chip or a QR code. Now what happens is this sheet is stackable. Multiple sheets, 70 to 80 sheets can be stacked in a single truck and can be transported to the site. Similarly, when we go on the site, this sheet folds up to form a perfect box. Then you can place the reinforcement and do ready mix concreting or concreting in that box. So this becomes a embedded kind of formwork, and this is how we are achieving very low transportation cost. We are achieving 90% reduction in transportation cost. So basically the fundamental difference here is what we are doing is, instead of pouring the concrete in the blocks at the earlier stage in the factory where it is not required, we are simply transporting the dead weight of the concrete. But what I am doing is I am simply putting the concrete into the shells or molds at the mm, last part of the process, which is the erection and assembly. So when the panel comes from assembly, then we pour the concrete and make it a superb strengthy panel. Now, who are the beneficiaries? First of all, are the builders, institutions, and the government. So, there are government institutions like SIDCO, MHADA, and other builder institutions like L&T, Tata Groups, Shapurji Pallonji, Lanco, HCC, and many more who are looking forward to reduce this transportation cost, and then they are perfect beneficiaries for us. Also, the inhabitants of the affordable housing schemes and slum rehabilitation schemes are praying for genuine solutions which are durable and safe at their required cheap costs. Moving forward, what are our value propositions? First of all, we have stackability. Each and every panel can be stacked upon each other to form a really long and big stack, because we have designed our panels using fiber reinforced concrete. They are very good in taking the vibratory loads that come during transportation. Also, these panels are lightweight. So imagine a situation like in Arunachal Pradesh, you have to airlift the panels from one location to other because there is no access to roads. You have to construct a school in Arunachal Pradesh. How will you do that? You cannot lift 2 to 3 tons of a panel using a helicopter. So here, what's where the prefabricated technology comes into the picture. We can airlift these structures, we can put it and then use locally available concrete to do the casting. Then we have installation benefits that I'll discuss in next slide. And of course, a panel that is a lightweight is very easy in erection, because a 30-ton crane will take a 8-ton panel and place it. The workers will have many difficulty in placing it in its actual spot. But here, a 800 kg panel is easy to carry around and place in its required spot. So that is the advantage. So in this picture, what you are seeing is the installation of ducts and installation of wiring and all the other things embedded into the slab. So there will be no nuisance under the slab like you see in the parkings of the malls. So cost cutting strategies, we do a majority 80% reduction in transportation cost, and this is very significant, I tell you, in any construction scenario. Then we give 35% less on power cost because the crane capacity and everything is reduced. Then final dead weight of the structure, which is an indication of the seismic performance of the structure, reduces to 20%. Also, we are using betons and voids which are saving concrete, and our construction design saves concrete up to 30%. That's why the total carbon emissions reduction, including transportation and everything, is 30%, which is also substantial towards our sustainable development goals. Moving forward, what are our USPs and what are modes? The sheet that you are seeing laying below is made by us by using our own concrete mix design of fiber reinforced concrete. Also, our own reinforcement design that you saw for forming grid beams inside the structure is patented, and IPR is available from us. Also, IoT induced RFID chip for post maintenance and smart construction project management is one of our USP, because for example, I'll give you the Morbi bridge collapse, but no one would be found accountable for that. So whenever the inspection of any bridge happens, they simply can come to the RFID tag, scan it, and fill their information. So whenever you visit that bridge, or a safety engineer visits that bridge, he gets all the data log of each and every past maintenance that has been happened to that bridge. So this is a major USP of our construction IoT forms. So now moving forward to our goals and objectives, I am going to design a full-scale prototype which will be 1 RK residential in a record break time here in Ahmedabad itself. Now for that, I need to get some proof of concept, which I have already got, because I tested one of the blocks using this technology in a government facility to gain required strength and required confidence that I can go ahead with this prototype. So that is one major achievement and a major milestone in my journey. And I also I am on the verge of taking technical and industry validations. So we have almost completed them, and we are applying for certification of CBRI and BIS. Now this is the picture of how our first prototype will look like. It will be a 1 BHK house which can be directly given to the beneficiaries under Pradhan Mantri Awas Yojana, which falls under all the specification required for the Pradhan Mantri Awas Yojana. This is its plan. Now, what will be its feature? It will be made using fully our technology, so it will be fully prefabricated. Its erection and completion will be done in record break time. We can break the record of Limca Book of Records here in Ahmedabad, and we can have a great media coverage out of it. A target rate of 750 rupees per square feet, compared to what industry standard is 900 to 1100 rupees per square feet. Also, we are giving better structural performance than current market standards in Pradhan Mantri Awas Yojana in any given scheme. So this prototype I am planning to construct here, and that's the main reason why I required these funds. And this will be a great solution. This will be a great way to show people how this technology works in action. Also, talking about market sizing, the total addressable market here is 200 billion. Actual construction market in India is more about 700 billion dollars, but it has been staggered into conventional construction and precast construction. So here we are talking that our targeted market is 200 billion and SAM is 40 billion for us. Now, moving forward to the proposed cost and fundings, what is my ask? I required a fund of 10 lakh rupees to make this dream come true, because the major part will go in raw material. Also, I need validations, a lot of certifications, a lot of testing to be done before erecting the final prototype. So the allied cost with those are 3,25,000. Also, fabrication, synthesis, and making an SOP of entire thing will require another 95,000 rupees, and patent filing cost, business travels, and contingency will also acquire for some minute amount. Now, what will be the work plan? The completing design and finalizing SOP will be done in the next 3 months. We are already on the verge of completing completing this part. Then selection of material sizes, making first iterations, iterating optimal performance will be 2 months. Small scale mock-up sample testing experiment will be 5 months, and then the full scale prototype, which is fully conditional and groundbreaking, will be constructed by 12th month of this project. So it's time to meet our fantastic team. This is Atharva Patil. I'm the founder and CEO of Hope Infracon. I'm a civil engineer by profession. I've done it from VGTA Mumbai. Also, currently I'm studying in postgraduate diploma in management in the course of own venture development in EDI Ahmedabad. This is my co-founder Pramod Lavan. He's also a maverick structural engineer. So he's a BTech civil in structural engineering. Currently, he's the head of transmission and design, Burns and McDonald's, and he's working with us part-time. This is Meera Pillai. She's working with us full-time. She's a BTech electrical engineer, and she has her forte in automation engineering and production management. So it's time to meet our mentors. The first one is Shri Anay Masruwalaji. So he is a role model and a partner head in marketing and quality control at Venus Engineering Works. He's also an integral member of the PDPU IIC team. Mr. Satyarajan Acharya, HOD Department of Entrepreneurship, EDI. So he has vast amount of connections and vast amount of knowledge in the entrepreneurial ecosystem. And Vikas B. Varekar sir is my technical mentor. He has done his PhD from environmental engineering from IIT Bombay. Currently, he is associated with the Brun Mumbai Municipal Corporation's slum rehabilitation drive. So what are my hopes from Nidhi Prayas and especially PDPU? First, I need industry connect and mentorship. So networking and connection, reaching out, how to reach out big players and take assistance in technology refining and business model. Then validation and credibility. Through the different validations, we are going to gain the required credibility into the market. And I know that PDPU has a fantastic fab lab, so I need the access to that lab in order to develop my prototype. Also, funds required for the full-scale prototype that were mentioned in the couple of slides. So thank you. That's been my time. I hope you understood the concept. Any of your questions are totally welcomed. And so just for your reference, this is a cost sheet of how we are going to achieve the rate of 750 rupees per square feet. So this costing parameters that we have used is costing for 100 units for a standard panel, which is 8 by 4 feet, to be delivered 100 kilometers away from a factory. So this is the costing parameter that we are using. So that's been my time. Thank you very much. I hope you enjoyed.